Good afternoon, everyone. Thank you for being here and listening to us talk about leveraging eBPF and OpenTelemetry to auto-instrument exemplars. So before we get started, I just want to take a quick moment to introduce ourselves. Hi, I'm Kruthika, and I'm a machine learning engineer at Apple. I work with the observability team, and my experience is in observability, machine learning, and data science. And I've been at Apple for about 6 years. Charlie?
Hi, I'm Charlie. I've worked at Apple for about 8.5 years. I've had roles from SRE, DevOps, and observability. I'm a software engineer at Apple today, and I'm also a maintainer for Cortex, one of the projects in CNCF.
All right. So, if you're here today, and it doesn't matter what your background is, if you're an SRE, you're a developer, you're a DevOps engineer, you will take away how to use exemplars to supercharge your observability and your debugging abilities. So what are we going to cover today? We'll talk a little bit about what exemplars are and what eBPF is. We'll go into how you can use eBPF to auto-instrument exemplars. And then we'll talk about projects that use OpenTelemetry to create exemplars with eBPF, and we also have a demo for that. And finally, we'll talk about how you can, and how you can use machine learning to supercharge your exemplar observability. Okay, so imagine this. Can you guys still hear me? Okay. Imagine this, that I have a service, and I'm noticing that the request latency, there seems to be something off with that. So what is the first thing I do? I go into my dashboard, and I look at my request latency graph, and indeed, it looks like something is wrong. It seems to be going up. But I just cannot use only this metric to debug what's going wrong. I still need more information. So the next step that I do is I go to my distributed traces, and now I have to sift through this plethora of traces to figure out which request path is that of the slow request. And obviously, we all know how tedious that is. But what if there is a way for me to go from metrics directly to traces? And the answer is, there is a way to do it, and that is through exemplars. Exemplars are time series data points that essentially link metrics to traces and logs through the trace ID and span ID. And these are often stored alongside metrics in the metrics data store. They provide a lot of contextual information because it's not just the traces and logs. You can add a lot of other attributes to the exemplar as well. OK, so here is an example of what an exemplar looks like. So let's go through what attributes are there here. So the first thing that we see here is the trace ID, which is essentially what you would use to go from the metric to the trace. That is the link between the metric and the trace. We also see a value here which says 1016, which is the value of the metric itself. And the metric is some sort of a histogram metric, as we can see here. It says bucket. So the bucket it belongs to is the 2500 bucket. There is LE in between. That is the bucket. And the other attribute of importance is the span ID. So the trace ID and the span ID is all that is there in this exemplar to point you from the metric to the trace. And the way that the exemplar is instrumented is you can see this little yellow dot. I guess we went to the next slide. Little yellow dot here, that's the exemplar. So that's how it looks on your visualization. OK, so now let's say that I'm convinced that I need to instrument my application for an exemplar. What do I do next? I need to go and essentially instrument every single application that I have to instrument the detailed telemetry that I need to collect for exemplars. So I need metrics, I need traces, and then maybe I want to add logs. I will need to instrument all of this. And it just doesn't end at my application. If I'm interacting with external applications, I will have to instrument those applications as well to collect these exemplars to get the complete picture. And obviously, you can see that it's a lot of overhead, not just time, but also it could be a performance overhead. But what if I told you that there is a way for you to auto-instrument your applications for exemplars? And the way to do that is through eBPF. eBPF is a superpower inside of the Linux kernel that lets you run small programs within the kernel without actually modifying the code for the kernel or the application itself. And this can enable you to have high-performance observability without modifying the application itself. So what is the advantages of having eBPF for auto-instrumentation? One of the biggest advantages is that you have to do zero code instrumentation for your application. And even with that, you get high-resolution visibility into what's going on. And they integrate pretty well with the Kubernetes observability stack, so you're improving the observability of your applications. And because it's at the kernel level, they are event-driven and highly efficient. So now, let's look at a quick demo of how you can use eBPF to auto-instrument exemplars. Charlie?
Cool. Thanks, Kruthika. All right, so here's going to be something exciting. We're going to do a live demo. But I wanted to quickly give you a big picture of what we're about to do in the demo so that it makes sense. What I'm going to do is set up a local Kubernetes cluster on my laptop and then install these components into the cluster, and then have traces and metrics automatically be generated for all these services that are talking to each other without having to actually instrument any of these services. So these are just binaries that you can download upstream that haven't been instrumented with exemplars. And I'm going to be using Bela here, which is a project from Grafana that lets you have auto instrumentation, and then lets you also generate exemplars from the metrics and the traces. So this is just a quick picture of what I'm going to do. I'm going to change over to my terminal here to actually show you what I'm going to do here. So let me make this bigger. Okay. So I'm going to be using something called Kulima to set up my Kubernetes cluster. I already have one installed, so I'm not going to run this again, but I'm just going to be using K9s to show you that I have a cluster running on my machine. It just has a couple of pods on there that are like essential to running the cluster, but other than that, nothing is really installed. On the left-hand side, I'm going to run Helm file to install all of the charts that I'm going to be using to get this working. This is probably going to take a couple of seconds, so I'm going to show you what I'm going to be installing here. So on the left here, you'll see that I'm using SeaweedFS to emulate S3 on my laptop because I don't want to use Wi-Fi here. Bela is the project that I'm going to be using to have eBPF instrumentation. Jaeger is where I'm going to be storing all of the traces that gets collected. The OpenTelemetry collector is what I'm using to route the metric and traces to the various backends. Prometheus is where I'm going to be storing the metrics with the exemplar data. I'm using Grafana here to visualize the metrics and the traces. And then Cortex is a project that I am a maintainer for, so I'm going to be using it to show how a microservice is set up without any instrumentation for exemplars can be automatically instrumented without any manual instrumentation. And this is kind of the magic here that I wanted to show. So it looks like everything on the right side is up. You can see I have Cortex as a microservices setup installed in the Cortex namespace. I have Bela here, Grafana, Jaeger, the collector, the server, and then the 3 pods we started at with the beginning. I'm going to port forward here to the local Grafana instance here so that I can interact with it from my laptop. And then I'm going to run a command to set up some data sources and dashboards. So I don't have to do that here. But so now that that's going, I can go over to my localhost and then be able to visualize some dashboards here. So I've made this Exemplars dashboard here, which is actually showing us exemplars. So I have some metrics here that are coming from a Cortex binary that I did not touch at all, and I was able to get metrics, traces, and exemplars out of that. So the distributor is, let me step back and talk a bit about what this service is. So Cortex is a project that allows teams to have like a very horizontally scalable Prometheus. So it basically lets you send metrics to Cortex, and then Cortex will be able to manage that for you at a very large scale. So imagine just like being able to horizontally scale Prometheus across multiple nodes, and then making it very highly available. So the first thing that usually metrics touches when it comes to Cortex is the distributor service, and that fans out metrics into the ingester service, which then stores the data. But you don't really need to know all of that to kind of get the picture here. Distributor here is one of the services that I'm showing here. These are metrics that are coming out of Bela for this specific service. So it's showing me the specific post request method, the status code, the HTTP route. This is nothing new, but what is new is the idea that you can jump from this metric to the trace. Like this, for example, I'm gonna just filter for one of the series here that I'm looking at, which is an RPC client request. So this shows me here, I'm just gonna click on one of these exemplars here. And this shows me that the service name that I'm looking at is the distributor. It's talking to the ingester. This is the value for how long it took. So this is a latency metric for how long this specific RPC request took. So in this case, it was 5 milliseconds. It was in this 10 millisecond bucket. So it's a histogram. This is the RPC method that was called. So you can see that these are the various attributes of the span that was in this request to make this whole thing happen. And also, if you click on View in Jaeger UI, you can see the exact trace as well. So from that metric, I looked at an exemplar and then jumped to that trace to see more information about it. And I can drill in more here to see, okay, in this specific span, what were the various attributes that were related to that request. And I just wanted to re-emphasize here again, I didn't have to instrument Cortex manually. Like Bela was able to instrument the kernel itself, which all these different services are talking to collect that telemetry of which services was talking to what kind of request was it, what was the status code, and Bela was collecting that and sending that off to Prometheus and Jaeger to store it as its telemetry backend. So that is the quick kind of thing that I wanted to show. That was the distributor. I can also look at another service that's here inside of Cortex. This is another, so the ingester is where the metrics actually go when it comes out of the distributor. So I can see here, this is some of the things that it's talking to. So it's talking to seaweed.fs to see if the blocks are there. So it's doing all these other things, and you can kind of get a picture of what's going on without actually having to instrument the service itself. So this is like a superpower for free, right? So if you're an SRE, let's say you're managing a bunch of services, but you don't have a lot of context into it, right? This is sort of turning black box mirroring into white box, right? You're able to see what's going on inside of a specific service and then get more understanding of what's going on. Okay, so I also wanted to show the query side. So these two things were like the ingestion side. So when you're sending metrics to Cortex, that's the ingestion side. I wanted to show if you could query Cortex, what would that look like? So I'm going to go over here. This is a nonsensical query, really. This is a very expensive query. I wouldn't recommend running this in production. But what it's doing is essentially summing up every single metric and grouping it by name. And this is just to have some payload on Cortex so I can visualize some requests going on. But then in Cortex, you can actually see some of these requests that are happening here. So all of these are 200. The query range request is the one that I'm most interested in. So I'm going to click on that, and there's some exemplars here, fortunately. So this is what the Grafana is talking to Cortex, and then this is the exact amount of time that the query front end took, and I can click on View in Jaeger. So far, this demo is working great. So what we're actually seeing here is Grafana itself, which I, again, did not touch or instrument. It just has this instrumentation generated for us out of the box. And I was able to collect all of that info and send it off to Prometheus and Jaeger to store it for us. And then I'm using Grafana itself to query. So this is kind of like meta level thinking here, where I'm showing the thing that I'm instrumenting using the thing that I'm instrumenting it with. Which is really cool, right? So you can play around with it and then see how everything works, and it's all in your laptop, and you can experiment more with it. And the best thing is, like, it's all OpenTelemetry, right? So the stuff that's coming out here is OpenTelemetry native. So the events that are coming from the kernel, they get translated into OpenTelemetry signals, which then gets routed off into the backends that know how to support OpenTelemetry, which is really, really cool. So this is like a lot of work in the making here from many, many people. So thank you to the OpenTelemetry community for making this possible. Okay, so I wanted to stop there for the demo, and I think I wanted to hand it back to Kruthika to talk more about how everything works. Maybe I'll just quickly recap what I just said so that it all makes sense, hopefully. So I deployed Cortex, Grafana, Bela, Prometheus, Jaeger, all into a local Kubernetes cluster so that I can just have everything here for the demo. And then Bela here is listening, or basically telling the kernel, hey, send me these network events when they happen. And then Bela translates them into OpenTelemetry signals. And because Bela here is generating the trace and the metric, it's able to inject that trace ID into the metric to create an exemplar, and then forward that off into Prometheus so that when you query that metric later, it'll have that trace ID in there so that you can find that trace in Jaeger. Okay, now I will hand it back to Kruthika. Thank you.
All right. Thanks, Charlie. So now that we've seen a demo of how you can auto-instrument exemplars with eBPF for any application, he showed quite a few of them, so that's pretty impressive. So now let's talk about what are some of the benefits of exemplars. So the biggest benefit is that you get precision debugging. Because they link high-level metrics to the traces directly, you're going straight from the alert that you get to the root cause itself. And I'm not saying it gives you the root cause. You can root cause the issue much faster. And the opposite of this would be that you're actually having to go and look into your traces and see which one is the relevant trace for you to figure out what's going wrong. So it's really that powerful. So the next one is that with traditional metrics, any outliers that are in the data and that are momentary outliers usually get hidden because there is some aggregations that most of these metric data stores apply. So you may not see them when you're trying to look for them, but the great thing about exemplars is they highlight them because, as you saw, it adds a little data point onto your graph, and that really shows you that something went wrong, and those outliers can be caught more easily. It has very context-rich observability. We saw the example. We saw the exemplar in the demo, and you can see that it has so many attributes, not just the trace ID or the span ID. There's so much more information there, which kind of, it's telling you a story, and it's not really just a data point anymore. You can do faster incident response, again, because you're not flipping through a million dashboards just to figure out what went wrong. It kind of helps engineers going from the symptoms to the cause in just seconds and not minutes. And finally, it opens up a slew of ML analysis that you can do on exemplars that give you even more observability into your applications. And we'll talk a little bit about this a little later. So let's quickly talk about auto instrumentation versus manual instrumentation. So manual instrumentation is good. The advantages is that because you are the domain expert and you have full control of what you capture, you can add a lot of domain context into the exemplars that you're extracting. And this just means that you have more depth of information in the exemplars. And they can also work across many languages or libraries. But for manual instrumentation, you actually have to go and change the application code itself and redeploy them. So it requires code changes and redeploys. And the risk of you missing coverage is a little higher than if you were trying to auto-instrument it, because auto-instrumentation would kind of cover most of the breadth of use cases that you would need. So with auto-instrumentation, the advantage is that you don't need to do any code changes for your application. And it captures more low-level signals like syscalls or network latency requests like we saw. And it is ideal for black box scenarios. So for example, I think Charlie spoke about this. If you are not familiar with an application and you just want to have some more observability into that application, it is great for that kind of a use case because you can implement auto-instrumentation at the kernel level and you'll get a lot of information there. And it's also good for legacy services. But the downside is that it's limited to what the kernel sees, and it's harder to capture deep business impact level semantics. Okay, so now let's talk about how you can supercharge your observability, or as I call it, observability plus, with adding ML on your exemplars. So when the worlds of exemplars and machine learning meet, the most important feature that you get is labeled anomaly detection. As you know, in real-world applications, labeled data is very hard to get. So most of our anomaly detection methods are unsupervised, which means they are not running on labeled data. But the great thing about exemplars is because they mark outliers in your data, you already have labeled data of what is an anomaly. So you can actually perform labeled anomaly detection, which is supervised anomaly detection, and they are far more accurate than unsupervised methods. You can do root cause recommendations, or even to an extent root cause analysis much better, because you have more types of information. You not just have metrics, you also have the trace and the log that corresponds to that metric. So you're able to do root cause recommendation more easily. You can do proactive alerting. And you can have feedback loops, which is you can say that an exemplar that your auto instrumentation has marked is a real exemplar, a real outlier, or not a real outlier. So feeding that kind of data back into your anomaly detection or root cause recommendation services is very, very essential. And finally, you also unlock multimodal analysis. So let's talk about what multimodal analysis means. So today, we live in the world of large language models, where we all have now learned to throw whatever data we have into the large language model, and it often coughs up something that is valuable to you. So why not do the same thing with exemplars? You have three modalities or three different types of very rich data. You have metrics, logs, and traces, and not individually. You have them linked with one another. You have very, very contextually rich information. So throwing this at the large language model unlocks, again, a large number of features for you, like incident classification, root cause analysis, incident summarization. You can get the large language model to write your RCS for you as incidents happen. You can do a lot of other summarizations as well. You can also further take this into doing root cause analysis and finding you a fix as well. Maybe you have some information that you've already documented, previous RCAs, runbooks, all of those can also be fed as metadata into the language model, along with the information that you're getting from the exemplars. And this can take you from root cause analysis to also recommending a fix, which will reduce your MTTR even further. So why can't you do this with metrics, traces and logs individually. You can, but the amount of data that you would throw at a language model would be more. But in this case, you are providing very specific information about your application to the language model, so you will get better output. So that's what exemplars can do for you in a nutshell when you have machine learning applied to them. So before we close, let's look at what our key takeaways were. We looked at what exemplars are and what eBPF is. Then we spoke about how you can use eBPF to auto-instrument your exemplars. We also spoke about projects that use OpenTelemetry to create exemplars with eBPF, and also saw a demo of how you can do that. And finally, we spoke a little bit about how you can use machine learning to supercharge your exemplar observability. So we hope that you are more motivated to use exemplars as part of your observability stack moving forward. And yeah, we're open to questions now. Thank you.
Do we have time for questions?
Maybe you can just come. Maybe you can just come.
I'll just come over there.
Yeah. All right.
Hello. Oh, hi.
Hi.
Forgive me, this is a naive question, because all I know about eBPF is how to spell it. But layer 7 protocol parsing is famously difficult to do in a constrained compute environment like eBPF. I know other CNCF projects have tried and failed. So is the magic happening in Bela? Like, what is going on inside there? Is it actually parsing layer 7 inside eBPF?
So I'm not like an eBPF expert as well, but I was able to work with the maintainers of eBPF to add exemplars to what they were doing. So underneath the hood for how it talks to the kernel to like translate the network requests and then translates them into OpenTelemetry signals, like I know that's like what happens in general, but I don't know like if it's doing what you're asking, if it's translating the layer 7 things directly.
Okay.
I mean, we saw the demo. It was pretty, I think, comprehensive of all the different services that it was able to automatically instrument, whether it was a C service or it was written in Go. There are these hooks that Bela knows about, because basically for each kernel, there's the map, right, where there are these function calls that it expects to call when it talks to the kernel. And so Bela has this basically a dictionary of all these different function calls that it can call. And so it's able to recognize when that happens and then translates it into something that makes sense for a human. So either if it's an HTTP request or a gRPC request. If you want to know more, I would recommend talking to the maintainer of Bela. He would definitely tell you more about it. But thanks for the question.
That's great. I appreciate it. Thank you.
Mm-hmm.
Hi, thank you for the talk. I was just wondering, it wasn't entirely clear to me in the demo, the metric series with the exemplars, are they newly created by Bela, or is it somehow correlating existing histograms and somehow adding?
Yeah, so the metric series were created by Bela, and the exemplars were attached to those metrics that it created. But the metrics that it creates is an OpenTelemetry metric as well. So it would also conform to the semantic conventions that OpenTelemetry proposes. So if you have a dashboard that knows how to like look at semantic conventions, regulated metrics, then it should just work the same. And there's a lot of work to make it possible to have the Bela be included in projects that are already having manual instrumentation. So there shouldn't be a lot of like collisions between those two.
Awesome, thank you.
You're welcome.
Thank you for the talk. My question is, in the time series, there will be trace ID to cross-correlate between the metric and the traces. I think that's basic idea. But and there's also, I think, the log relation, right? Both metrics and logs could be, you will be able to, find the related event in traces or logs with a certain outlier metric. So when these things scale up, because I think this will be available for all data points, and there will be large cardinalities, and you will need to query lots of logs and metrics and traces. If it's not embedded in the exemplar itself, for machine learning or other the root cause analysis, you might need to sift through lots of logs or traces just to get the complete picture. So wouldn't it be a problem, or what will be the strategy to get the complete picture, embedding it into the exemplar already during the generation, or is there any strategy about that?
I think what you're asking is, because there's so much of logs and traces, if you just embed an ID, then would it be a lot of information to fetch?
Yeah, it will be hard to find the right trace ID between billions of traces, billions of logs, and you have an exemplar. If it doesn't have the full context, that's what I understood. You want to, let's say, do a root cause analysis based on some outlier data points, right? And you want to get the full picture. You need to find them by trace IDs, right? Everything's not in exemplar. That's the part I didn't get. What should be the context of the exemplar, or how much you need to get from the other relevant events.
Yeah, so that information is embedded within the exemplar. So you have a trace ID, which essentially points you to the particular trace that you need to look at. And the same with logs. You can look at a particular log, which corresponds to that outlier time series data point. So with exemplars, you get all three metrics, traces, and logs for a particular time window. And it's very limited context there, but it's very rich context. Okay. So you don't really have to go and sift through.
Go and fetch it.
Yeah.
Okay. Thank you. Got it.
Hello, very nice talk. I have one simple question. Is there any alternative dashboard for showing the exemplars despite the Grafana?
Not that I'm aware of. I did talk to the maintainers for Persis, the other sandbox, I think, project right now in CNCF that allows for querying metrics and traces. That was maybe a couple months ago, but they said they were looking into getting that working. But as far as I know, this is just one dashboard, or I think Grafana is the only one that I'm aware of that can show exemplars in a dashboard. The Grafana itself you don't need to necessarily use it. The idea is that it makes it possible to visualize, just like with an open source project. The idea of getting an exemplar is just in Prometheus, right? Querying Prometheus for the exemplar data. You can take that when you're querying the metric and then just add it on top of whatever dashboard that you're visualizing to be able to jump to the trace. So Grafana isn't doing anything magical here with viewing exemplars. They're just one company that's doing it right now. It wouldn't be very hard to add it to Persis, I would argue.
Thank you.
You're welcome.
Yeah, thank you for the talk. I have a question that is related to a previous question, and that's the gRPC method and also the HTTP path was included in the exemplar, as I saw. Yeah. So do you have any recommendation regarding scaling, because it would increase the cardinality? Because if I understood correct, it's really within the metric.
Right, yeah. So if you know that if you're basically allowing the route value to be determined by anybody that makes these HTTP requests, the cardinality could explode pretty quickly. So I would only do that if you're tightly controlling what kind of requests can be made to these specific services. If you know that it's like a open service that anybody can send requests to, I would add some filtering logic to drop those specific attributes before they get sent over, or do some pre-aggregation before, that makes sense so that you can still use it later. Yeah.
You could then, for example, correlate it, and you could then, for example, correlate it to a trace and get the path from there. Would that work?
Yeah, I mean, if you're sampling every single trace, yeah, that would be possible. Yeah.
Okay. Thank you.
Yeah. I think that's all the questions. Thank you.
Thank you so much.